in this video, we're going to use the Moivre theorem to find the power of a complex number and the nth term of a complex number. So let's start with our first problem. So in our first problem, we have the question. We should use the Moivre theorem to find 1 plus I exponent 6. So we need to go through some series of steps to find the answer for this question. So our first step, so solution. So we know our complex number to be 1 plus I exponent 6. Now this complex number is in the rectangular form. We need to convert this complex number into a polar form. So how do we convert a rectangular form of a complex number into polar form? We need to find the modulus of the complex number and the arguments of the complex number. So let's find the modulus of the complex number. So the modulus of a complex number is equal to R being equal to root of 1 squared plus 1 squared. And our answer here is root 2. Now, the argument of the complex number should be equal to the theta should be equal to tan inverse of 1 on 1. So tan inverse of 1. So theta is pi on 4. Now, when we are done with this, we can then go ahead and write our answer in the polar form. So the polar form, we should get R cos theta plus I sine theta. We know R, we know theta, so let's go ahead and write our answer in the polar form. So in the polar form, we should get root 2 multiplying cos pi on 4 plus I sine theta. So the theta is pi on 4. So let me just add it there. So pi on 4. Right. So when we are done with this, now this is our polar form of the complex number. Now we just go ahead and apply the Moivre theorem to solve the question. Now we know that in the Moivre theorem, it states that for any complex number, and we have that one to be z exponent n, which is equal to Rn op bracket cos n theta plus I sine n theta, right? Where n is any integer at all. So here we have z being equal to root 2, then cos pi on 4 plus I sine pi on 4. Very simple. So we have to calculate for R exponent n. So to calculate for that, we know our n here is equal to 6. That's the power here. So n is equal to 6. So our R here is root 2. So here we should get root 2 open bracket 6. And when we do that, we should get 8 for that. Now, when we are done, we need to calculate for n theta in front of the cos. We need to calculate for that. So n theta, we should have 6 multiplying pi on 4, and we should get 6 pi on 4. And when you simplify, we will get 3 pi on 2. Very simple. Now we are done with that. So 1 plus I exponent 6 should be equal to 8 cos 3 pi on 2 plus I sine 3 pi on 2. This is what we get. Now when we are done, we have to simplify the trig expressions in them. Now to simplify that, let's just take it one by one. So we have cos 3 pi on 2 and sine 3 pi on 2. So what is the answer for this? This one should be 0. When you input it into your calculator, you should get 0. And when you input this into your calculator, you should get -1 for this as well. Now we are done with that. Therefore, 1 plus I exponent 6 is equal to -8 and 8i. And this is our answer for 1 plus I exponent 6 using the de Moivre theorem. Very, very simple. Now let's go to our second question. In our second question, we are going to use the de Moivre theorem to find the third root of 8. Now in this question too, we need to convert this 8 here into complex number. Now this 8 here, to convert it into complex number, is 8 plus I 0 and is 8. That's why we have the 8 here. It means that the I here is 0. There's nothing there at all. We just have the real part of it. We don't have the imaginary part. So here too, we just go ahead and calculate for the modulus. So the modulus of this is 8, the 8 there. And the argument for this one is 0. There's nothing there. So therefore, the polar form of this is, so the polar form is equal to 8 open bracket cos 0 plus I sine 0, right? Then we apply the de Moivre theorem here to solve the question. So we have z being equal to r, then cos theta plus I sine theta. So we will use z exponent 1n being equal to r1n, open bracket, the cos theta plus 2k pi all on n plus I sine theta plus 2k pi on n. Very simple. So whenever you are going to find the nth root of a certain complex number, this is what you are going to use to find it. So here we have k to be 0, 1, 0, 1, 2, and n minus 1. So here we have our z to be equal to 8 open bracket cos 0 plus I sine 0, and our n here is 3 because we are finding the third term. So we first have to calculate for our r exponent 1 on n here, and we know our r is 8, so 8 exponent 1/3, and we get 2 for this one. So very, very simple. Very, very simple. So when we are done with that, we just also calculate for k being equal to 0, right? So I'm gonna clean this question here so that I can find space for this. So okay, so let me say this question is not, so let me cancel this question here, right? So let's calculate for k being equal to 0. So you first calculate k being equal to 0, right? So k being equal to 0. So here what we are doing is we are calculating the argument for k being equal to 0, 1, and 2. So k being equal to 0, we have theta, then subscript 0 being equal to 0 plus 2 multiplying 0 multiplying pi on 3, and the answer is 0. So here root 1 is equal to 2 cos 0 plus I sine 0, and the answer is 2. Very simple. So now for k being equal to 1, that's the argument, we have 0 theta 1 being equal to 0 plus 2 multiplying 1 multiplying pi, then all on 3, and here we should get 2 pi on 3. So here for root 2 we have 2 open bracket cos 2 pi on 3 plus I sine 2 pi on 3, and when we do it we should get 2 open bracket negative 1 2 plus I root 3 on 2, and when we simplify we should get negative 1 plus I root 3. Very simple, very simple. Now our last one is for k being equal to 2. So for k being equal to 2, we have theta subscript of 2 being equal to 0 plus 2 multiplying 2 multiplying pi on 3, and we get 4 pi on 3, right? Then for the root of that, so root 3, we should get 2 open bracket cos 4 pi on 3 plus I sine 4 pi on 3, and when we simplify it we get 2 open bracket negative 1 on 2 minus I root 3 on 2, and simplifying it we should get negative 1 minus I root 3, and this is our last answer. So we have the third root of a to be 2, negative 1 plus I root 3, and minus 1 minus I root 3, and that's our answer. I know this is a lot, so this is the first part of this video. Meet me in my second video where I solve more examples of this kind of questions. Thank you for watching this video, and I will see you in my next video. Bye.